Okay guys, today we're retesting on graphing cubics and new test on graphing rationals. So, your retest review. Write the equation if the parent function f of x equals x cubed reflects over the x-axis, translated left 5 units and up 6. So remember, it's going to mimic a cubic. The transformations are reflection, which is a negative in front. We have 5 to the left, which means inside the function we're going to say plus 5 with a cubed on the outside, and then up 6 means we're going to add 6 at the end. How many zeros does a cubic function have? Remember that they have the amount that their degree is. So on a cubic it's a third degree, so they have 3 solutions, or 3 zeros. A quartic is a fourth degree, so it has 4. The domain and range of all cubic functions is going to be negative infinity to positive infinity, and so will the range. Okay? Describe the transformations of the parent cubic represented by the function. Well, it's got a vertical compression. The 1/3 shows you that it's a compression of 1/3. And it moved down 7 units, the -7. Shows us that it went down. Okay, number 5. We are going to use the Desmos app, so if you have it on your phone, go ahead and get it open. We're going to go ahead and graph this. So we're going to do parentheses, x, what is it, -3 squared, and then x plus 1. Oh, sorry, x -3 is not squared. Let me go back to that. So -3, close parentheses, and then x plus 1 squared. Okay, so that should be what the function looks like. Alright, so if you look at your graph, you've got all of the main pieces, and then you may have to zoom in or out to see the rest of them. So you can use your zoom button to be able to do that. So, my first question on the paper states the first question on the paper states how many x-intercepts. Well, remember, if it's a cubic function, it goes by the degree. And so this is going to be 1 and 2 makes 3. So there are 3 x-intercepts, which means the turning points are going to be at most 2. It's 1 less than the degree. Okay, x-intercepts. So we can go back to our Desmos, and looks like we've got 2 of them at -1, 0 and at 3, 0. The y-intercept, when we go back to it, is 0, -3. Oops. Okay, bouncing and crossing. So if you notice, a bounce is going to change directions at the x-axis. So in this particular one, if you notice, at this particular point right here, it bounces off of it and goes the other direction. But then at this particular point right here, it crosses. So the bounce is at -1 and the cross is at +3. Now we can also do that from how we learned it. Whenever you have an even number of factors, then it's a bounce. So we had 2 x plus 1s, that's an even number, so it was at -1, it was a bounce. And we had 1 x -3, which is an odd number, so that would be a cross. Okay, so the local min and the local max. You look at the function. The local min is going to be this point right here. It's a decimal, so 1.667, comma, -9.481. Okay. Oh, just kidding. That was our minimum, and I put that on the wrong. Sorry about that. Now let's look at the local max. The local max is at the high part of the turning point. So the min down here was the low part of the turn. This is the high part of the turn. So our local max is at -1, 0. You can have the x-intercept and the local max at the same point. Okay, so increasing and decreasing. Let's look at what the graph looks like. So if you notice, this turning point down here is where it's going to start increasing, and then we are also increasing on the left side of the grid as well. So when you're graphing over here, your grid or your graph is going to look like this. And so when it asks for the increasing part, the increasing is here and here. So we're going to use that turning point or that minimum to help us write the increasing. So on the left side, over on this part of the graph right here, it starts increasing at -infinity off the page. And then it stops increasing at -1. So remember that you are getting your number off of the x-axis. This is like doing a domain for that particular part that's highlighted in green. So -infinity to -1. You are not using the y's, you are using the x's. So look on the x-axis for your numbers. Then it starts increasing again down here at that turning point, but that's actually not a whole number. It's where this turning point is. So we have to use that particular x value. And that particular x value is 1.667. And it keeps increasing until you get to infinity. Okay? Now the decreasing part is the part that is in between these two increasing. So it's basically going in between those two intervals. So from -1 to 1.667, you have the decreasing part of this graph. All right, number 6, find the zeros of the function by GCF and factoring. So the first thing we're going to do is take out a GCF. And when we take out the GCF, we are going to have x squared plus x minus 2. Now this, two factors of -2 that add up to 1, are x plus 2 and x minus 1. So those are going to be my factors, which will set equal to 0 to get my zeros in just a minute. Okay, the degree of the function is a third degree. The leading coefficient, that's what LC stands for, is a positive. It's 4 if you want to actually write it. End behavior, this is a cubic function with a positive leading coefficient. So it's going to start down and end up. Okay, the zeros, we're going to set each one of these equal to 0. So 4x equals 0, x plus 2 equals 0, and x minus 1 equals 0, and we're going to solve. So we're going to have 1, 0 at 0, we're going to have 1 at -2, 0, and we're going to have 1 at +1, 0. The y-intercept, we're going to sub in a 0 for all of the x's, and when we do that up in the original equation, we end up getting 0 plus 0 plus 0 when you put a 0 in there. So my y-intercept is going to be 0. And again, that's all we're doing is substituting in a 0 where all the x's are in that first equation. So it ends up being 0. Okay, cross and bounce, they are all going to cross because if you look at all the factors, we only have 1 4x, we only have 1 x plus 2, and we only have 1 x minus 1. So all three of these zeros are going to be crossing, and none of them will be bouncing. So we're going to put none right there. Now let's graph it. When we graph all of our zeros, and we realize that it is going to start down and end up, we're going to just sketch this. And again, we're sketching. You can look at your calculator to see what it looks like, but it takes on the cubic form with end behavior ending up. Okay, part 2, graphing rational functions. So on all of these, remember that you have to simplify the equation first. So the first thing you're always going to do is factor. If you look at the first one, there is nothing that can be factored out of 3x plus 1, and there's nothing that can be factored out of 2x minus 1. So that is the simplified equation. Now we are going to use the simplified equation for all the rest of the answers. Okay? So there is no whole, and the reason there's no whole is because in order to find the whole, you have to set the canceled factor equal to 0, and we didn't cancel anything, so there's no whole. Vertical asymptote is setting the denominator equal to 0 and solving. So my vertical asymptote is going to be at 1/2. Okay, you have to solve for x. So my vertical asymptote is going to be at 1/2. Okay? Horizontal asymptote, you got to go to the degree. The degree of the numerator is 1, the degree of the denominator is 1, so they're the same. If they're the same, then you revert to the leading coefficients. And the leading coefficients on these are a 3 divided by a 2, so my horizontal asymptote is at 3/2. The x-intercept, we're going to take the numerator, which is 3x plus 1, and set it equal to 0. So we're going to subtract 1, giving us -1, and then divide by 3. So my x-intercept is going to be at -1/3, 0. Remember, that's a point, so don't put x equals. You need to put -1/3, 0. Y-intercept. The y-intercept is setting a 0 or substituting in a 0 for all of the x's. So that's going to be 3 times 0 plus 1 divided by 2 times 0 minus 1. So this is going to end up getting 1 over -1. So my y-intercept is going to be at 0, -1. Okay, let's graph this and then we'll be able to figure out our domain and range. Well, yeah, we'll do that first. So my vertical asymptote is at 1/2. So just graph that in between 0 and 1. My horizontal asymptote is at 3/2, which is like 1.5, so that's between 1 and 2. My x-intercept is at -1/3, so that's going to be about right here. And my y-intercept is at 0, -1. So I know just by knowing that those points are on my grid that my two branches are going to be in the bottom left and in the top right. They always need to be opposite of each other. So now my domain and range. Remember, your domain and range are all the reals, but we have to leave off where our asymptote is. So x cannot equal, make sure you put a slash, what our vertical asymptote is, which is 1/2. And for our range, our y cannot equal whatever our horizontal asymptote is, which is 3/2. Okay, number 2, we're going to have to factor it first before we can give the simplified equation. So I'm looking for 2 factors of -15 that add up to -2, and those are going to be a +3 and a -5. So -5 times 3 is -15, -5 plus 3 is -2. On the bottom, I'm looking for 2 factors of 21 that add up to 10, and those are going to be 7 and 3. So when I do that, I'm going to end up canceling the x plus 3's, and so your simplified equation is going to be x minus 5 in the numerator and x plus 7 in the denominator. Okay, for the whole, remember the canceled factor has to be set equal to 0, so I ended up canceling an x plus 3. So the whole is at x equals -3 when you solve for x. Vertical asymptote is the denominator equal to 0, So I'm going to set x plus 7 equal to 0 and solve, which puts my vertical asymptote at -7. Horizontal asymptote, you got to look at the degree. Remember, we're using the simplified equation. So this is what we're using. Degree of the top is 1, degree of the bottom is 1. They're the same. So you're going to refer to the leading coefficients, and that's 1 divided by 1. So my horizontal asymptote is 1. X-intercept, that is the numerator equal to 0. So x minus 5 equals 0, which means my x-intercept is going to be at 5, 0. Y-intercept, we're going to sub in a 0 for all of the x's. So this is going to be 0 minus 5 divided by 0 plus 7, which is going to give us a -5/7 as our y-intercept. So remember to write those as points. Okay, the domain, set of all the reals, x cannot equal -7, and y cannot equal 1. Okay, so I'm going to graph my vertical asymptote at -7 and my horizontal asymptote at 1. My x-intercept is at 5, 0. And my y-intercept is at 0, -5/7, which just is going to be close to -1. So I know that my branch is going to come somewhat like this. And if it's in the bottom right, then it has to also be in the top left. Now, the last thing I want to do is graph that hole. So in order to graph the hole, you're going to go to where the hole is at, which is -3. And you're going to go to where your graph is, and you're going to erase it and put an open circle in its place. So it should look like that. All right, for number 3, we're going to factor the top, -5x divided by x plus 3 and x minus 3. That's a difference of 2 squares. Nothing can cancel. So we're left with just what we wrote. So -5x divided by x plus 3, x minus 3. So since nothing canceled, I don't have a hole, because the hole is where the canceled factor is equal to 0, and we don't have one. Vertical asymptote, we got to take the denominator and set it equal to 0. So we're going to do x plus 3 equals 0 and x minus 3 equals 0. We have 2 of them. So this is one of those special cases. Okay. Horizontal asymptote is the degree. So if you look at the degree, we've got 1x on the top and 2 x's on the bottom. So this is a situation where the bottom is bigger than the top, so your asymptote is at 0. X-intercept, we're going to set the numerator, which is -5x, equal to 0. We're going to divide by -5. And that's going to give us an x-intercept at 0. Y-intercept, we're going to sub in zeros for all of the problems. But if I sub in a 0 for that numerator, it does not matter what's in the denominator, because -5 times 0 is 0. So my answer is going to be 0, 0, because it doesn't matter what I divide 0 by, the answer will be 0. Okay, so let's graph it and then we'll do our domain and range. We have a vertical asymptote at -3, and we have a vertical asymptote at +3. And then we have the horizontal one at 0. Our x and y intercept are at 0. And so now what I would do is I would graph it to make sure that we have it in the right space. And so I would, we want to make sure that we have the S in the middle going the correct direction, and that we have the 2 branches in the correct direction. So, okay, so if you notice, the 2 branches, when you graph it, just to look at it, the 2 branches are in the top left and bottom right, and the S is going up. So when I graph this, I want my function in the middle to go up, and these are going to be my two branches. Okay? All right, the last, or almost. So we've got x, two factors of -6 that add up to 1 are going to be +3 and a -2. And then two factors of 12 that add up to 7 are going to be x plus 3 and x plus 4. So my x plus 3's are going to cancel, and my simplified form is going to be x minus 2 over x plus 4. So the whole is going to be at -3. That's the canceled term equal to 0. Okay? Vertical asymptote is the denominator equal to 0. So this is at -4. Horizontal asymptote goes to the leading coefficient because the degrees are the same. So this is going to be 1 because the leading coefficient is 1 divided by 1. X-intercept is the numerator equal to 0. So this is 2, 0. Y-intercept, you have to put the zeros in for all of the x's. So this is going to end up being -1/2. -1/2, sorry. -1/2. Okay, your domain is going to be all the reals, but it cannot, x cannot equal -4, which is where my asymptote is. And my range is all the reals, but y cannot equal 1, which is where the asymptote is. So, -4 is the vertical asymptote. +1 is the horizontal asymptote. We've got an x-intercept at 2 and a y-intercept at -1. So my branches are going to be in the bottom right and the top left. Okay, number 5. You're going to work backwards on number 5. So it asks you to write an equation of a rational function with vertical asymptotes at x equals 3 and x equals -6, a horizontal asymptote at y equals 1, and x-intercepts at 6, 0, and -1, 0. So we're going to work backwards. If the vertical asymptote is 3 and -6, then that means that my two binomials were x plus, just kidding, x minus 3, in order to have a +3 as an answer, and x plus 6 in order to have a -6 as an answer. Now, vertical asymptotes are when the denominator is equal to 0. So that means that this had to be our denominator. Our denominator had to be x minus 3 times x plus 6. Okay? Now, the horizontal asymptote being a 1 means that the two degrees had to be the same, and my leading coefficient had to be the same number. Could be 1 over 1, 2 over 2, 3 over 2, 3, whatever. So we'll check that at the end. The x-intercepts are my numerators. If the x-intercept is a 6, then it was a -6. And if it's a -1, then it was a +1. So we ended up having x minus 6 and x plus 1 on the top. So when we multiply that out, when you multiply that out, you're going to basically use the box method on the top and the box method on the bottom, okay, to multiply those out. So you would do x minus 6 and x plus 1 and x minus 3 and x plus 6. And so you would end up getting x squared minus 5x minus 6 divided by x squared plus 3x minus 18. And if you notice, our horizontal asymptote, if both of the degrees are the same, then you go to the leading coefficients, and the leading coefficients are 1. So it works. All right, for number 6, all you're doing is looking at the picture and coming up with the information. So the vertical asymptote, you're looking for the vertical dashed line. That's at x equals 2. Horizontal asymptote is the dashed line horizontally. That's y equals 1. The x-intercept, so we're looking for where it crosses the x-axis. It looks like that's at -5. Y-intercept is where it crosses the y-axis, and that's going to be at, ooh, that's ugly. It looks like 2.5. We're going to go ahead and estimate that and make it a -3 for nice purposes. Okay. The domain's going to be all the reals. There's no hole in this, so it doesn't matter. And x cannot equal 2. And my range, all the reals, but y cannot equal 1. Okay? And so now the possible equation, if I've got a vertical asymptote at 2, then that means that my denominator was x minus 2. If I have a x-intercept of -5, that means the top was x plus 5. Okay? So that would be my possible equation. Those are the two pieces we needed to know. And we're done.